Okay, just testing this out. Ooh, I found a better tip. That's better. Okay, we're going to look at these two polynomials, f(x) and g of x, and the first thing it says, it wants us to find the zeros of f of x. So remember that if you have a polynomial, you want to try and see if you can factor in order to try and find the zeros. But if you can't factor, then you might have to do some synthetic division. So when I first look at this, I notice that these have an x squared in common and those have a 2 in common. So if I just try regular grouping, it seems like that might do something. But then 6x and the negative 8, if you take a 2 out, you're left with a 3 and a 4. It's not going to work out for us. So we're going to ignore all of that, and we're going to go back and think about our rational zeros. Remember that we could look at our possible zeros, the possible rational anyway. And that was looking at the factors of the constant term. So we have the factors of negative 8, so we're going to have plus and minus 1, plus and minus 2, plus and minus 4, and plus and minus 8. And we divide those by the factors of our leading coefficient, which would be a 1. So we're going to have plus and minus the 1. So we're going to just test out a few possibilities by using synthetic division. And so I'm going to start by trying like a 1, because it seems like 1 or negative 1 seem to work a lot. So let's try this. We got 1, 3, negative 6, negative 8. Bring down our 1 here, multiply. We're going to add those together, multiply again. Left with negative 2, multiply again. 1 doesn't work. So then I try, okay, well, how about negative 1? So we have 1, 3, negative 6, negative 8. Bring down the 1 again. We'll get negative 1, a 2, negative 2. This looks promising. We get negative 8. And then a positive 8, which makes 0. Woohoo! That means negative 1 is a 0. So now we're going to take this and say, okay, since negative 1 was a 0, that means that x plus 1 is a factor. And then looking at these coefficients, we're going to have x squared plus 2x minus 8 is the other factor. But then this can factor more. So it looks like we're going to have x plus 1 times, all right, we need x times x will make the x squared. Then we need numbers that will multiply to negative 8 and also add to 2. That would be a 4 times a 2, and we'll keep the 4 positive and the negative 2. So now if these are the zeros that we're looking at, well, trying to find anyway. We're looking at, we would get x will equal a negative 1, a negative 4, and a 2. Those are the zeros of that function. So the next we want to look at the zeros of g of x. So the zeros of g of x, we're going to have to go through a pretty similar process because it also will not factor using our regular ways. So we're looking at the polynomial. G of x is x to the third minus 2x squared minus 5x plus 6, and we want to see when that equals 0. So let's try again. The possible rational zeros are going to be plus and minus 1, plus and minus 2, plus or minus 3, plus and minus 6, all over plus and minus 1. So I'm going to start with 1 again. 1, negative 2, negative 5, 6. Bring that down, we get 1, 1, that's negative 1, negative 1, negative 6. Woohoo, we found it first try, yay. So then that means that this 1 would come from the factor x minus 1. We have x squared minus x minus 6 as the remainder or leftover polynomial. But then this can factor some more. We have x and x to make the x squared, and then we'll have a 3 times a 2. We need to make negative 6 and add to negative 1, so we have negative, positive. And so our zeros are going to be 1, 3, and negative 2. So next we're going to look at finding the x-intercepts of the graph of f of x. So remember that the x-intercepts are really the real zeros. So if we look back, we already know that f of x had the zeros of -1, -4, and 2. So all we really have to do is come back down here and write those as ordered pairs. So we're going to have that the x-intercepts of f of x are going to be -1, 0, -4, 0, and 2, 0. Similarly, the x-intercepts for the graph of g of x, we're just going to look at the zeros up above, and we're going to end up with the x-intercepts are going to be 1, 0, 3, 0, and -2, 0. So remember that when you have the zeros, if they're real, those are going to be the x-intercepts of our graph as well. Okay, now we're going to go over to this rational function. So what it's taking here is the same rational function, or the same functions we've been dealing with, but it's writing a fraction of f and g. That's our new rational function. So if we want to find what the x-intercepts are for our graph r of x, remember that a fraction is equal to 0 if 0 is in the numerator. And so that would mean that we're looking at when f of x is equal to 0. And we already know from number 1 that our function is equal to 0 when x is equal to the -1, -4, and the 2. So that would mean that our x-intercepts are going to be -1, 0, -4, 0, and 2, 0. And for the next part, when we want to look at the vertical asymptotes of this same rational function, it's saying, okay, when is this fraction here undefined? And so when we know that a fraction is undefined if you have 0 in the denominator. And so this is going to be when our g of x equals 0. And so we know that we are undefined, our g of x is equal to 0 when x is equal to 1 and 3 and -2, which we saw on part 2 of this worksheet. And lastly, we're going to look at finding the horizontal or slant asymptote. So if we have this horizontal asymptote, it's going to be found when the degrees, by looking at the degrees of our polynomials, because what we're really asking for is what's happening as x gets really big or x gets really small. Since these degrees match each other, we're going to look at the leading coefficients, which are 1 and 1. So we know that our horizontal asymptote is going to look like 1, or you say 1 over 1, which is really 1 when x's get really big or really small. So then the next thing that we want to do is try and see if we touch this horizontal asymptote. So to say if we touch, it's really saying when is our y equals 1 touching this graph. In other words, we're asking when does x cubed plus 3x squared minus 6x minus 8 all over x to the third minus 2x squared minus 5x plus 6, when does this equal 1? And so if we want to solve a rational equation like this, we're going to try and clear out the denominator. So we're going to first multiply both sides by that x to the third minus 2x squared minus 5x plus 6, and then we'll do the same thing over here. So that will be, let's see, make some room here. We have, let's see, so we multiplied over there. Okay, here we go. We're going to multiply by x to the third minus 2x squared minus 5x plus 6. But really all that's going to do is get rid of that denominator. So then we have x to the third plus 3x squared minus 6x minus 8 is equal to, well, it's kind of nice having a 1 over there. So then all we have is x to the third minus 2x squared minus 5x plus 6. And so as we try and solve that equation, one nice thing is that the x to the third, so we're gonna be able to cancel those guys out. So those are gone, whoop, those are gone, those are gone. So we're left with 3x squared minus 6x minus 8 and negative 2x squared minus 5x plus 6 on the right hand side. So we're going to try and put all of our x squareds together. So really let's just move everything over to the left side. So I'm going to add 2x squared, add 5x and minus 6. So we have equal to 0. Do the same thing on both sides of our equation to maintain our balance. So then this leaves us with 5x squared minus x minus 14 equal to 0. We could try and factor this thing, but it really doesn't look factorable. So then that makes me want to just go straight into using the quadratic formula. So remember that the quadratic formula says that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So for us, our a is equal to 5, b is equal to negative 1, and c is equal to negative 14. So we're going to get x equals negative 1 plus or minus the square root of negative 1 squared minus 4 times 5 times negative 14. This is all over 2 times 5. When we simplify this, it's going to be 1 plus or minus the square root of 1 plus 20 times 14. So we're going to get 280. Let's scoot this up. And this is all over 10. So x is equal to 1 plus or minus the square root of 281 over 10, which if we plug that into a calculator, you have 1 plus the square root of 281 over 10 is going to be 1.776. And you do 1 minus the square root of 281, you're going to get negative 1.576, about. So it's going to be at these two values where we cross our horizontal asymptote.